we're gonna do electrolysis of not molten but aqueous stuff. Right, so let's do the same thing again. Draw the battery, plus, minus, draw the electrodes, then panic. Positive is anode, so this is anode, and negative is cathode, so negative is cathode. That's where you're at. Electrons flow out here and carry the charge. Right, let's draw the container with the electrolyte. Did we define it earlier? Yes, okay, we've done all that. I'm not interested in all that. Right, okay, now what we're going to do is we're going to use sodium chloride in water, aqueous solution. So let's try to look at it this way. So you've got sodium chloride. Sodium is a +1, chlorine is a -1, forms a -1 ion. Then you've got water here. Now a good way to look at this is, let me just do this. Look at this as in it splits up into a hydrogen and a hydroxide ion. Right, so what we've got is we've got H plus and an OH minus. Right, now what's going to happen is the positive ions are going to get attracted to the negative electrode. Them two are going to head off that way, and they go that way. So what I'm going to do is I'm going to move these about. Let's move these about. 1, 2, 3, 4. Right, let's move you over there. Let's move you over here. Let's move you over here. Let's move you over here. Oh, they want to do that. Come on, what's going on? Right, okay, so look, this is where we're at so far. Now what we need to do. Right. Let's just move this out of the way. Right. There's different mnemonics for this, but the way I've figured it out is please stop losing careless marks always. And then I just say chicken like this. That's carbon, non-metal, hydrogen, non-metal. Please stop losing careless marks always. Zebra is, and then you've got your 3 metals, and if you look at your periodic table, they're all after one after the other. Copper, silver, gold. Copper, silver, gold. It's in the periodic table in that. So this is the reactivity series. The reactivity goes down. It decreases, yeah. So this is the most reactive. Now, so remember, when you've come out of a test and your results are not very good, your teacher says, please stop losing, let me do this, please stop losing careless marks always. You've got your chicken, and then you've got zebra is, and then you've got your three metals, copper, silver, gold. They're all in the periodic table in that order. Now what all we do is we add this potassium. Remember, these are metals, metal reactivity series. Sodium, lithium, calcium, magnesium, and it's aluminium. It is not aluminum. Right, okay. You've got zinc and you have iron. Copper, silver, gold. Copper, silver, gold. Now, going back to this, if you look at these two, sodium's there and hydrogen's there. So sodium's the most reactive out of them two. So sodium wants to stay as it is, so it's going to stay like this. So then hydrogen is going to go over, pick up an electron, and become a hydrogen atom. And then another hydrogen ion is going to do the same thing because these are diatomic. Once it's in a pair, it's going to float off as a gas. So can you see what's happened? Right, the next bit's a bit trickier. So let me just rearrange this if I can. Right, let me just delete whatever we don't need. Delete, that's gone, that's gone, that's gone, that's gone, that's gone, that's gone, that's gone. And we'll put H2 here. Right, now the same thing on this end. You've got chlorine and hydroxide. So you've got chloride ion, hydroxide ion. Right. So what you've got this situation here. The hydroxide ion is slightly more easier, right? Right, so it's slightly easier to oxidize. It's easier to lose an electron from here. This negative tells you it's an electron, an extra electron, so it's easier to do that. So really what we should be doing is splitting this hydroxide ion up. But because there's that many more chloride ions compared to hydroxide ions, what happens is chlorine drops off, or chloride ion drops off an electron, becomes a chlorine atom. Another one does the same thing, and they pair up and they float off as a gas. So you end up with the chlorine gas floating off. Yeah. Let me just write gas instead. Gas. So now what we can do is we can get rid of that. No, we can't. What's going on? No, 1 second. It's playing up again. Right, we're back. It's working. Right. So let's get rid of you. Let's get rid of you. Why did I want to do that? What sort of crazy maneuver was that? Right, let's leave it like that. So now what we've got is chlorine gas at the anode, hydrogen gas at the cathode, and we've got hydroxide ions floating about near the anode, and we've got sodium ions at the cathode. So in the solution we've got sodium hydroxide solution. Right, spare with me. Right, okay. So now if we leave it long enough, we're going to end up with sodium hydroxide solution. Right, okay. What else do you need to know? Right, what we'll do is we'll crack on with this actually. Right, we're trying to electrolyze aqueous sodium chloride. So we know in here we've got sodium chloride, so always put this in, helps. And you've got water which breaks down into hydrogen ion, hydroxide ion. Now, the positive ions will go to the negative side. The negative ions will go to the positive side. So this is what's going on in your head, yeah? Then what did we say? So let me just put them on this side so you can see this. Once you can see this, it's not actually as bad as it looks, to be honest with you. So let's get rid of that. Right, and let's put them on that side. So we'll put hydroxide ion and chloride ion. And then what did we say? Let's just use that. Right, you've got hydrogen ion, sodium ion. Sodium is more reactive than the hydrogen in the reactivity series, so it wants to stay like this. It wants to stay as Na plus a sodium ion. So what happens is this goes over, picks up an electron, becomes a hydrogen ion. Another one goes across, picks up another hydrogen electron, becomes a hydrogen ion. These two join up and they become hydrogen gas. Right, remember the word diatom, oh my goodness me, diatomic molecules. And we said no. And then you've got your group 7 fluorine, chlorine, bromine, and iodine. And that's all we're interested in. Forget astatine. They're diatomic in the natural world, so they run around in pairs. So that's why we're expecting 2 of these. We're expecting 2 of these. So we've got H2. Right, on this side, the hydroxide ion is what do you call it, more reactive, but only slightly. But because there's a lot more chloride ions, what happens, that goes across, drops off an electron, becomes a chloride ion. Another one goes across, drops off, another chloride ion. These two are diatomic, they join together. This is how you've got to view it. And you're going to have chlorine gas in there, chlorine gas. And then, where are we? Let's get rid of U. 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 Right, so what's left in the solution is really sodium hydroxide. Right, so this, all this stuff, if you can learn the way sodium chloride works, you're on your way. That's half the battle. So describe a test at the positive is chlorine. So what's the test for chlorine? It turns damp litmus paper turns it white, or it bleaches it. I can never spell bleaches. Right, gas A will be hydrogen because the way we've just described it. Right, Some of the solution formed after electrolysis was tested with an indicator. Phenolphthalein turned it pink. Right, okay. Let me just go through this. This is how I like to write it out. Alphabetical order. Acid and alkali. And you've got neutral. Then what I do is I'll put universal indicator and litmus paper. I start with these two. I know they are red in acid and they are both blue in alkali. Universal indicator is green when neutral, and this is purple. I've come to that conclusion. That's probably the best way to remember them because of the mark schemes when you look at those. Right, then you've got something called methyl orange. Let me write that there. Methyl orange is another indicator. This is better, and I just remember Roy. Red, orange, and yellow. And then you've got phenolphthalein. Phenolphthalein will be I can't see Pink Panther. That's how I remember it. Right, you don't say clear, say colorless, and then it turns pink when it's alkali. So that's how you can remember the 4 indicators. That's only for the higher. Okay, it's pink. Why is it pink? Because we have hydroxide ion. Hydroxide is alkaline. Okay, so that's going to be pink. So it's the hydroxide ion turns it pink. Right, here we've got a half equation. No, we're not interested in that. That's not in the spec anymore. Okay, let me just quickly do it. So it's 10 Faradays divided by 2 because it's diatomic equals 5 moles of chlorine. Because no, did I just right? Let me say that again. I'm such a liar. I need to stop lying. Right, I need to stop lying. So it's 10 Faradays divided by, you need 2 moles of electrons to get 1 mole of chlorine. Right. So we've got 5 moles of chlorine multiplied by the volume for 1 mole is that, and you end up with 120 decimeter cubed. Right. We're not interested in that. Right, we're going to call it quits here. We'll try this question on the next. So it'll be sodium chloride, and when they say solution, they mean aqueous. We'll come back to that. Right. Thank you.